Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET exam. So I will be starting the discussion soon here in the session, but before I'm going to talk about the important concepts and the points here, I will be just checking it out whether everything is all right and clear your side or not, and then we will be continuing the discussion too. And if there is something which is not clear to you, wherever you are gonna have any doubt, you can just let me know about it and we will try to consider those points as well. So let me just quickly check it out whether everything is okay and clear your side or not, and then I'm going to continue the discussion. Is it audible or not? I'll have to check it once, just a second. It should be audible, guys. Is it audible your side? Is it all right and clear now? All right? But I am not able to hear it my side. I think there is some issue. Yeah, it's okay now. Done. Very good afternoon, everyone. So that means if everything is all right and clear, even your side, that means we can continue the discussion. And as you can see, today our session is about the most important discussion on quantum mechanics. Okay. So if in case anywhere, whatever discussion we will be doing right now, if you will find like something is not getting clear or somewhere you are having any doubt, just mention it at the same time. I'll be talking about it. Thank you so much, Harita. Thank you so much, Neha. Thank you so much, Priya, for letting me know about it, that everything is all right. Very good evening, Shilpa. Very good evening, Neha. Very good evening, everyone. So let's continue the discussion, guys. So before I'm going to start the discussion about these important topics and concepts here in this session, I would like to share a few updates with all of you. So the first one is regarding the new batch course, which is starting soon, which is going to start soon on Unacademy. This batch will be starting on 11th August. So if anybody is there who wants to join the regular live classes of well-structured and well-planned courses by the top educators, in that case, you can take the Unacademy Plus or the Iconic subscription, and you can take the subscription as well as you can start joining the sessions of these well-structured and well-planned courses. So you can see the referral code has also been mentioned here. So if you're going to proceed further to take the subscription, you can use and apply the referral code, which is Anjali Alive, as mentioned here on the screen. By using and by applying this referral code, you will be able to get the discount in the total subscription amount. As this is going to be a detailed batch course, so if anybody will be joining the sessions of this batch course, will be able to know about so many important topics, concepts, and many important points there. Along with that, if I'm going to talk about next important thing here, that's going to be, these are some of the important slides about the session. Along with that, about me, like all the details have been shown here regarding eligibility, qualification and all. Few more important things about the community post, okay, and the new feature we are having in the learning app. So about that, you can have a look at this slide. You will be able to get an idea, okay, that how it will be helping you to have a better understanding with the any important information you will be having there, okay, on the learning app and all. This is about the Iconic subscription. So if anybody will be taking the Iconic subscription, then what are the benefits you will get? All that has been mentioned here on the slide. And again, whenever you will be proceeding further to take the subscription, use and apply the referral code, that's Anjali Alive, as mentioned here on the screen. By using and by applying the referral code, you will be able to get the discount in the total subscription amount. These are the benefits you will be getting if you will take the Plus subscription. So if you are going to proceed further to take the Plus subscription, you can have a look at the benefits which you will get whenever you will be taking the subscription. Along with that, guys, you can use and apply the referral code, which is Anjali Alive, whenever you will proceed further to take the subscription. This is about the Lite subscription. So what are the benefits you will be getting if you will take the Lite subscription have been shown here. Now the difference between the Plus and the Iconic subscription has been shown here on this slide. which will even be making the things more clear to you. Done? Now we are ready to talk about the important concepts, topics, and the points which we need to consider in this session today. So I hope you all are ready for the further discussion. Done? Very good evening, everyone. So let's just start the discussion about those important topics, concepts, and the points from the quantum mechanics section, which we will be considering here today. Okay? If in case anywhere you will find that something is not getting clear to you or somewhere you are gonna have any doubt, you can surely let me know about it. While we will try to do the discussion in this session in such a way that even if somebody is there who is going to do this subject preparation just now and has not considered it yet, so still with this session you will be getting so many important points related information, so that even after attending this session, if you will go and check out the previous year questions, okay, you will find that most of those questions you will be able to solve and you will find them quite simple and easy for you. Done? So one session, just for some time, you are gonna attend it and you are gonna gain so much knowledge that it will be helping you to work on different type of questions from quantum mechanics part. But the one thing you have to do when you are attending this session is focus. That's it. Let's just start the discussion now. So basically, guys, if I'm going to talk about the first thing I will be considering here, that's the important systems related information. Because if I'm going to talk about a question which is related to probability, which is related to expectation value, which is related to some other thing, for example, perturbation theory, which is related to any other concept, okay? So in that case, mostly we need to use the systems related information there. And that means the first thing everybody needs to know, along with the differences, the mistakes you can make there, and you have to be more careful about those points, all that I'll be making clear to you. So let's talk about the systems now. First system I'll talk about here is the 1D box. Along with that, I'll be sharing the information about the symmetric and the asymmetric cases too. If I'm going to talk about the 1D box, guys, what is the 1D box? One-dimensional box, which is also known as the 1D potential well. It can be symmetric, it can be asymmetric as well. What I mean by symmetric and asymmetric, very important. This is the point where you can make mistake if you will avoid it or you will not be focusing on it. Now let me just explain that point to you so that any time whenever you will be solving such type of questions, you will not be making any mistake and it will become quite simple and easy for you to relate it, to solve it correctly, and to get the answer quickly and easily too. For example, there is a box you are considering. Let's say it is extended from 0 to 2L or 0 to just L or 0 to L by 2 or 0 to 5L, anything. I'm not fixing that value that it should be only this one. No, it can be 0 to 2L, 0 to L, 0 to L by 2 or anything. That's okay. We are accepting it. Next thing. If I'm going to talk about another case when it's the box extended from minus L to plus L, minus L by 2 to plus L by 2, okay? Or it's going to be minus 2L to plus 2L. It can be anything. So you can see the difference between the two cases. This is 0 to something, 0 to something, 0 to something it can be. The second case is from negative value to the same positive value. This is what? It's showing the symmetry. So we will call it the symmetric potential well. Did you get this? Oh great, we got to know about the symmetric potential well, but why we need to know about it? What is gonna be there if it is symmetric? And this is a symmetric potential well. Great, you got to know about it now. So this one is symmetric and the other one is asymmetric. Done? Are you all getting it? It's gonna make a big difference in your answer. If you are going to avoid it, you can get the wrong answer in the exam and you can't take a chance, because even the 1 mark or 0.1 or 0.2 marks are even very much important for us. Okay, to clear the cutoff, to score good marks as well as to have good rank in the exam. So we can't take a chance anywhere at any point, and for that we need to be careful about all these points. Let's talk about the next thing now. So once you got to know about the symmetric and the asymmetric potential well, next thing you have to consider is the system related information. Where there will be a difference, I will tell you. Where symmetric and asymmetric cases will be making difference? In the wave function part. Okay, wave function will get effect with the symmetric and asymmetric cases. How? We will be talking about it. But firstly, I wanted you to get the clear idea about it, that how symmetric and asymmetric are different from each other and what is the difference between them. I hope you all have got it now. Let's talk about the next thing. So the 1D box, if I'm going to talk about the potential expression corresponding to the 1D box, since it is 1D, I can also show it as the Vx. This sequence, if you will be following, which I'm going to give you right now, will make the things quite simple and easy for you, and will make it easy for you to understand and to keep the things in mind, the formula concepts and the points. So Vx can have the values as 0 and infinity. Now from the potential expression, you will get to know whether it is symmetric potential well or it is asymmetric. How? So here you will have the range given to you as 0 to L. For example, this is given to you 0 to L. Okay. Now, otherwise it's going to be what? It can be infinity. Done. This is the one case. It can have the equal to's given or not given there. That's okay. But this is how you're going to have it. Clear? This is what, can anybody mention it in the comments? Is it the symmetric case I'm going to talk about right now or asymmetric case? Quickly in the comment section, just mention it. Is it symmetric or is it asymmetric? If anybody is going to get it, mention that in the comments. If you will not be mentioning it, in just some time I'm going to say that too. Okay, so it is symmetric or it is asymmetric. Just have a look at this. Mention. 1, 2, 3, 4, and that's it. It's final 5. Very good, Kuldeep. Very good, Harita. It's asymmetric, and that's correct. Okay, because we have talked about it. If it is starting from 0 and this is how it's going to have the range given to us, it's what? Asymmetric. Very good, Shilpa. That's great, guys. Now, once you got to know about the potential expression and you got the idea that how potential expression is going to help you to know about it, whether it's the symmetric case or the asymmetric case, the next thing we have to prepare is the wave function expression for the nth state. So for the 1D box, what will be the wave function expression? Let's talk about it. It's going to be root 2 by L. L is what? The length of the box. What is the length? Initial and the final limits difference. Now when I'm saying difference will be positive. Then the greater value minus the smaller value. L minus 0, that's L. So root 2 by L. Even if I will take 2L here, so difference will be 2L. So length of the box will be 2L. L by 2 I will take there, it will be L by 2, then you will have. So root 2 by L sine nx pi x by L. Since it's the 1D case, it's not necessary that I have to take the suffix here showing it that it is for the x, because only it's the x term we are going to have here. So that's okay, I can even remove it. I can simply write sine n pi x by L. But here comes a big point. What is that? That is simply what are the allowed values of n we can have here. It's very important to have a clear idea about it, otherwise we can make mistake in this section too. Like further, we will talk about the harmonic oscillator, and if you will not have the idea about the values which are allowed for n, okay, in different cases, you can again make mistake. So that's the another point where you have to be extra careful about. What are the allowed values of n? Be careful about it. They are starting from 1 for the expression we have noted down here. 0 is not allowed. Means even if somebody will be saying, okay beta, find the ground state wave function for the 1D box for which you are using this wave function expression. So ground state means n is equal to 1. Same with the energy expression which I will provide you here. For that, the allowed energy values will be starting from 1. So let's talk about it. En, that's going to be nx square, or simply n square pi square h square square upon 2 ml square. That's it. This is how you are going to write it. Now again, what are the allowed values of n you can have here? They will be starting from 1. So simply write it 1, 2, 3 and so on to. I hope you all are going to get it. In case still if you're going to have any doubt or difficulty, let me know. This was the asymmetric potential well case, okay, or 1D box case, okay. You have to prepare, or you have to keep the potential expression in mind. You have to prepare the wave function expression, it's important for you. You have to prepare the energy expression. This is for the 1D case we have done this discussion. If I am going to talk about the symmetric case, what will happen? Let me just tell you, for the symmetric case now, I will be changing this limit, but the energy expression will remain as it is. Energy will not get changed. What about the wave function? It will be changing. How? Let me just tell you about that too. Okay, so have a look at this. So energy for the symmetric potential well will remain same, but the wave function will change. So I am going to remove it and I will tell you how it will be changing. For that, I am going to write it as minus L2 plus L. Then what is the length of the box? Can anybody let me know what is the length of the box now? If I have taken minus L2 plus L, please mention length of the box in the comments. If you are getting it, what is the length of the box? What is the length of the box here? Just check it out and mention it in the comments quickly. It's important for you to understand. Why? Because you will be working on the questions in the exam, and once you will be getting it, that's great. Very good, Harita. That's great. It is 2L. Okay. So final minus initial. So that is L minus minus L, which will be giving you 2L. That is the length of the box. Very good, Shilpa. Very good, Jitin. Very good, everyone. Very good, Kuldeep. Very good, everyone. That's great. Let's talk about the next thing now. So you are even going to see, or you are even easily going to get it. It is what? It is the symmetric potential well with the length of the box as 2L. So either I have to make the change here in the energy by taking the length 2L at that place, or we can do a little more smart work here, because I think we like the length to be L. Reason behind it, our formula becomes so easy. So I'm gonna make some changes in the symmetric potential well range. I'm making it minus L by 2 to plus L by 2. As you can see here, we have considered it. Okay, now great. Energy same, symmetric potential well. Where is the difference in the wave function? How it's different? Let's have a look at that. The wave function will have the two values this time. One will be root 2 by the length of the box L. If it will be 2L, I will write 2L here. But right now I have considered it to be L, so I am taking L here only. So root 2 by L sine n pi x by L. Or it can be root 2 by L cos n pi x by L. But here, to understand it, that which formula you will be using at what time, I'm gonna let you know something here. So guys, before we are gonna proceed further, to make it easy for you to memorize it, because see, it's easy for me to tell you in one line, and for you to memorize it further or without having any doubt, it can be difficult for you to consider it without any doubt. If I will just tell you, okay beta, take this for this, take this for this, without giving you any idea, any of the related facts, anything which can make it easy for you to memorize it or to keep it in mind for a long time, so that in the exam you will not be making mistake. So to make it easy for you, I'm gonna give you one example. If there is a function and I'm gonna have that function as fx, what I'm gonna do, I'm gonna make the changes in its x values, whatever x values there. So for example, function is x square, and I'm gonna replace the x with minus x. So I will be getting it as x square, which is going to be equal to fx itself. So f minus x, for this function, I've got it same as fx. Done. In this case, what will happen? It's showing the condition of even function. Even function. If any function satisfies this condition, that you replace x with minus x in that function and you get the same function back, you will be calling it the even function. Okay, great. But at the same time, for example, I'm taking the example of a function which is x cube, and I'm going to replace x with minus x there. So what I will get? I'll be getting minus x cube, which is equal to minus of fx. So it is what? It is showing the odd function condition. So the conditions for the even and odd functions I wanted to tell you: f minus x is equal to fx, even function; f minus x is equal to minus fx, odd function. I hope everybody is going to get it now. Now the next thing I have to consider here is that once you got this fact, do you know that we are going to have, Jitin, any doubt you are going to have anywhere? If yes, mention it. If no, that's great. So I'm going to remove this part here. If you are having any doubt, mention it just to make it more clear and to have more space. Done? So let's remove this part. If I'm going to talk about the next thing here, guys, that is cos is what function? Is it even or is it odd? So cos minus theta, you may have seen whenever we write, for example, I'm writing cos minus theta, it is also equal to cos theta. It is the trigonometric functions property. Okay, means in cos theta, even if I'm replacing theta with minus theta, I'm getting the same function back, which make it the even function. So which means cos is what? It's the even function. Cos is what? It is even function. Okay, just a second. So when cos is the even function, same way if I'm going to talk about the sine, so sine minus theta is what? That's going to be minus sine theta as per the trigonometric function property. Sine minus theta is equal to what? Minus sine theta as per the trigonometric function property. So in the sine theta, if I'm replacing theta with minus theta, I'm getting minus f theta, okay, which is odd function. So now sine is what? Odd. Cos is what? Even. Sine, odd, cos, even. To memorize it, even there can be somebody who is having confusion in keeping it in mind. Which one is odd? Which one is even? So already in the cos, one O is present. Ek second. Just a second, guys. Just a second. Let me just get that slide back. We were talking about this thing. Sine theta, cos theta. Cos is what? Even function. Sine is what? Odd function. How to keep it in mind? Either with the property which I have told you. Here in cos O is there, in sine there is no O. Cos में spelling में क्या आ रहा है? O आ रहा है, but इसमें O नहीं है. So this is what? Even. It doesn't need more O. It doesn't need more O. One O is already there. It is not having O. It wants the O to be there. So odd. Done. So this is just for someone who finds it difficult to keep it in mind, whether it's odd function or even function, while I think if you know the property, you will easily be able to get it. Then let's talk about the next thing now. That's going to be related to this part, that now what will be the difference in the wave function. So we have taken the potential as, we have taken it 0 and infinity. 0 for x lying between minus L by 2 to plus L by 2. And otherwise we were having the value of the potential as infinity. Okay, now if in this case I'm going to write root 2 by L cos n pi x by L root 2 by L sine n pi x by L. Done. So in this case cos is what? Even function. So allowed values of n corresponding to it will be even. Oh, it is even now, so it will be odd. Even के साथ में odd आना है और odd के साथ में even values आते हैं. ठीक है? Opposite. It's even function, so odd values of n. It's odd function, so even values of n. Means here 1, 3, 5, 7, so on to. Here 2, 4, 6, so on to. I hope you all are gonna get it. But still, if you will have any doubt, just mention that. Now we will be doing some revision, quick revision, okay? And quick means quick. How? I'll be saying some state and you will mention cos or sine in the wave function for the symmetric potential well. Ready? Say yes in the comments if you are ready to answer. And those who will be saying yes, I will be accepting or I will be expecting their response in the comment section when I will ask you a question. Are you ready to revise it quickly? When I will say some state, okay, for example, ground state, what will be their cos or sine? So you will just quickly mention either cos or sine, or in short, you can write just to provide some hint regarding that. Tell me, ready? Let's start the revision. Okay, and quick. So let's see how easily and how quickly you are gonna get the answer. First one is second excited state in symmetric potential well wave function. Second excited state, cause or sign? Mention it in the comments quickly. Second excited state, cause or sign? Quick, 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 quick. Second excited state, cause or sign? Mention, mention, mention. I'm waiting for your reply, guys. Second excited state, what will be there? Will you have the cause or will you have the sign there? Mention it. See, ground state 1, first excited state 2, second excited state 3. 3 is what? Odd. Odd means even function, means cause. Is that clear? Very good, Kuldeep. Very good, Harita. Very good, Shilpa. Very good, everyone. Done. If I'm gonna talk about the fifth excited state, quickly, fifth excited state. Fifth excited state. Very good, everyone. Now for fifth excited state, just quickly mention it. Fifth excited state, what will be there? Fifth excited state. So n value will be 6. Why? For ground it starts with 1. So first is on n is equal to 2. So fifth excited state will have n is equal to 6, which is even. Even means what we have to consider there. We have to take the odd function, which is cos. Oh, that's correct, guys. So when I'm asking for the fifth excited state, it's going to be n is equal to what? Just a second, just a second. I think we have just stated it wrong. Now look at this. N is equal to 6 for the fifth excited state. It is even, so odd function should be there, which is going to be what? Sine. And your answer, if it is sine, is correct. Done. So odd value of n, the value of the wave function will have even function in it. Even value of n, the function will have the odd. Done. So opposite. Even value of n, odd function. Odd value of n, even function. So I hope it's clear to everyone. Very good, Neha, Harita, Shilpa, Kavita, Kuldeep, and everyone. Clear? I hope this is something which is clear to all of you now. Let's continue the discussion and let me just tell you about the next thing now. So if I'm going to talk about the next thing, guys, it is regarding the next 2D case. Okay, for 1D you got to know about the potential, you got to know about the wave function, you got to know about the like the differences in the symmetric and the asymmetric case, you got to know about the potential and everything. I hope it's gonna be clear to all of you. Now next is for 2D case and for 3D case. What will be the differences? Let's quickly talk about that. 2D case, the potential expression can be shown as V as a function of x and y. 3D, V as a function of x, y and z. Okay. 2D case, it can be 0 and infinity values. Now for asymmetric, we will be doing the discussion, because for symmetric, you got to know about the concept, you got to know about it, that what is the difference in the symmetric and asymmetric case we will have. So that same difference you will keep on considering. Now, I'm just quickly going to show you what are the rest of the formulae you have to take if you got to know about the 1D case for 2D and for 3D. X lying between 0 to L and y also lying between 0 to L. Otherwise, the value is infinity. If in this case I'm going to talk about it, it's going to be 0 and infinity. 0 for x lying between, let's say, 0 to L, y lying between 0 to L, z lying between 0 to L. Okay. And otherwise the value is what? That's going to be infinity. Compare the potential expressions. If in case you will have any doubt, you can let me know about it. Let's talk about even you can have these equal to signs given to you. That's okay. You can consider them as well. Done. Next thing. Next thing is the wave function expression. So here you have to write root 2 by L sine nx pi x by L. Root 2 by L for cos. This is like for x, how you write the wave function. Okay, wave function is multiplicative in nature. So now next time we will be writing for y, root 2 by L sine ny pi y by L. This is what you will have. Done. If let's say it's going to be the length 0 to 2L here for y or anything else, So length corresponding to that I have to write. It doesn't mean that I will be writing just same length. No. For 3D case also, what you will do, the 3 terms you will be taking, corresponding lengths you will take, and you will write the 3 terms multiplied together in case of wave function. Here also the nx and the ny values which will be allowed will start from 1. What about the energy? Energy is additive in nature, while the wave function is multiplicative in nature. Okay. Harita, was your question same for this? See, wherever the width you are going to use now, the length of the box or the width, so you will be making that modification there. For example, it's 2L, so at place of L you will write 2L. Okay, for that particular case, means like I have shown you for the Y, so you are taking it only for the Y term, not for X. X kill is 0 to L tha, so you have taken just L there. But it is 0 to 2L for Y, so I have taken 2L here. Done? 1D symmetric, then only in that case also what you will do, you will be making the changes in the overall length of the box part. Means if it is 2L, so at that place you will write 2L, okay, at place of L. So whatever will be the width in the formula at place of L, make those changes, put that value, whatever will be given to you, okay. There is no issue in it, but accordingly you will just be taking those values. So wave function is multiplicative in nature, while the energy is additive in nature. So it's going to be what? Nx square, pi square, h square upon, just a second, upon 2m lx square. I can write lx square. Why? If it is the length of the box, that's 0 to L, 0 to 2L, or whatever will be given now, accordingly you will put it here. So Lx I have notified, which means whatever is the length given, just put it at this place. Plus ny square, pi square, h square upon 2m ly square. If it is 2L, write 2L at place of ly. Okay. This is how you will be able to get it and consider it. Done? So energy in 2D case, additive in nature, and you can see how it will get add for both the terms, and nx and ny values which are allowed here are again 1, 2, 3 and so on too. Next thing you have to consider here is that energy always increases. Okay, what I mean by energy increases, I want to say that, for example, I want to find the energy of the ground state. So nx and ny values will be 1 and 1 for that. Okay, ground state, the minimum possible values 1 and 1 for both. For first excited state, now I can see if the Ly is gonna be 2L, so I will get 4L square here. When I will take LCM, I will get 2 as a coefficient in this term in the numerator. So if I will be increasing the nx value for this one, my value of the overall expression will increase more and more. While when I will take the 1 for this place, okay, or 2 for this place, and I'm gonna take 2 for this place, there will be a difference. What I want to say, let me just show you. See, 2 nx square plus ny square, and rest of the terms are common. You can take them common, and then the LCM will be there. So I'm saying for ground state 1, 1. Okay. For first excited state, I'm saying that the energy should be increasing. It should not be this one here, then this one here, then this one here. No, it will always be, if it's here, then next here, the next here, the next here, it will be keep on increasing. There should not be anything in between which is having the energy less, then more, then less, then more. No, ground state, first excited state, second, third and fourth excited state, same way it should just keep on increasing, or it can have the equal values if degeneracy exists at some particular level. I hope you are gonna get that. But if no, mention your doubt in the comments. We will be talking about it. Done. So ground state means 1, 1, because there is no other minimum possible energy we can have. So 1, 1 for ground state. What about the first excited state? So this coefficient should be small and this should be large for the first excited state, because in the first excited state case, if I will increase this coefficient now, then in that case I will get more higher value than the value which can be the smaller one, okay, and that's possible to get here. So with 1, 2, I will get a smaller value, while with 2, 1, I will get larger value because its coefficient is large. So if I will allot the value 2 to this part, okay, its value will increase. I can't take a chance. I can't let it be more if the lesser value is still existing. So I have to take 2 and 1 and 2 first of all. The coefficient 2 is there. I have to keep this value small. So 1 and 2. Then next time I'll just see the value should keep on increasing step by step. So it's a trial method. Just put the value and see is there any possibility, or directly you are going to get it this way or that way. Okay, and that's how you will be able to get the idea about the steps you have to take, or to consider that what should be the minimum energy corresponding nx and y values, first excited state, second, and all. Like we will be taking the questions too, you will get the idea about it then. So this is how you got to know wave function, multiplicative, energy, additive in nature, whatever will be the length of the box given to you. Okay, accordingly in that expression at those places you will put those values. There is no issue in it. That kind of modification can be done from our side once we understood the formula. Okay, you got the 1D box, 2D and 3D box cases. Let's talk about the harmonic oscillator, as it is a very important system for you to work on the questions. Without these systems, it may be difficult for anyone to solve the questions of different types. So that's why we have taken it to be the first topic for our session today. If in case anybody will have any doubt anywhere, just quickly mention it. I will be talking about that too. Let's talk about the harmonic oscillator. As in the 1D box, 2D box and 3D boxes, or simply in the box case, we had the symmetric and the asymmetric potential well condition situation and the cases existing where we had some kind of difference too, okay, in the expressions. Same way in case of harmonic oscillator, you will find we are going to have isotropic harmonic oscillator and the anisotropic harmonic oscillator. You may have heard about these terms, but if no, I will tell you. Okay, isotropic, be careful about these words, and then an isotropic. Done? Iso and iso. Clear. What is the difference? Why they are named as like iso and aniso? What's the difference in these formulae and how we will be able to get that difference? Let's talk about it. So actually in case of isotropic now, omega x, omega y, omega z, basically I want to say that the frequencies along angular frequencies along all the directions will be same. In anisotropic, automatically you got to know if it's not same, it's anisotropic, and if it is the same situation, it's isotropic. It's important for us to understand. Now you can have the question that even if two are not equal, is that anisotropic? Obviously it is. Whichever is not satisfying the all equal condition is an isotropic case. Okay, while all equal, iso means same. Okay, same means iso. So iso means equal and iso means not equal. Done. Let's talk about the next thing here. When I'm going to talk about the 1D condition, 1D harmonic oscillator. In 1D case, will you have anything to compare with? Like I have given you the example, if omega x and omega y are not equal or they are equal. So in 1D, there is nothing to compare with, okay? Means it's always the common case. So in 1D, you can't compare with anything. It's normal case, one case only. So that's going to be, its potential expression will be half m omega square x square, whatever is the case, because there is nothing else to compare with now. So potential, this main expression. With potential you will get to know, oh, I am going to talk about the harmonic oscillator. So it's important for you to keep the potential expression in mind too, because that will help you to compare with the formulae and to identify the system. Don't forget to consider this too, or whatever I am discussing in the session is important, will be helping you to work on the questions and to get the answers quickly and easily. Let's talk about its nth state energy. That's going to be n plus half h cut omega. Right now, from the harmonic oscillator part, I'm just going to talk about the energy and potential. Reason behind it, wave function is even there, but it's going to have the Hermite polynomial expression and quite different kind of expression. And from that section, we are going to consider it in the special classes. We generally talk about that as well when we take this topic, but this is most important. Okay, now if I'm going to talk about the n value here, so that will be having the values allowed from 0. So you can see in the box case the values were allowed or starting from 1, but now the values are starting from 0. It's important for you to know. Now in this case, if I will talk about the ground state energy condition, so you have to put the n value 0, then first excited state n value 1, second excited state n value 2. Potential and the energy should be clear to everyone. You can't miss even a single point out of these ones. Once you got it, this was the 1D case. So no comparison, nothing like that. Now let me just show you the comparison cases. If I'm going to talk about the next thing here, what is that? I'm writing the 2D case potential. Vxy is equal to half m omega square x square plus half m omega square y square. Or generally we also write it as omega x square omega y square, but I wanted to show you the omega x and omega y values, so I'm not taking their suffix, I'm just writing it in general. So half m omega square common, in the bracket I will be having x square plus y square. Coefficients are same, okay, no difference in the omega x and omega y value, that is just equal to omega, hence isotropic. Same way, if I'm going to talk about the anisotropic condition, Vxy is equal to what? Half m, okay, that's going to be, let's say 2 omega square, okay, and x square plus half m omega square y square. Now it's not necessary that you will have the 2 omega square given to you here. It can also be given to you here. For example, let me just show you how. 2m omega square x square. But you know that harmonic oscillator potential standard form is half m omega square x square. You know it? Means half must be there. To get the half, what you have to do now? You have to multiply it with 2 and you have to divide it by 2. Half you will be getting, that is 1 upon 2. But 4 extra term you got. Now you will include it where? In the omega part, which is going to be 2 omega. Done? So what is omega x now? That's going to be 2 omega in this case, because 2 omega square you will write. So you will be writing it as half m 2 omega square and x square. This is how you will be considering it. Done? So that is what omega x. At the same time, if I will talk about the next thing here, that's going to be half m omega square y square. What is the omega value for it? That's omega. For this one, 2 omega. It is what? An isotropic case. Same way for the 3D, if you will be writing it, you will have the 3 terms there, okay? Isotropic will have all the omegas same and isotropic will have all the omegas different. So this is how you will be getting to know about it. While when you will write the energy expression, for example, for this case, you are going to write it. So nx plus half h cut omega x plus ny plus half h cut omega y. And what are the allowed values of n here? That will be just starting from 0 for nx and ny both. Same way here, either you can just equate omega x is equal to omega y is equal to omega. So nx plus ny plus 1 h cut omega, if you will take nx plus omega x is equal to omega y, okay? If they are equal, just put or replace omega there and then you will be getting this formula for 2D case. Same way for 3D case, what will happen? Okay, omega x plus nx plus ny plus nz plus half 3 times you will be adding, because your main formula is n plus half h cut omega. So 3 times means 3 by 2 you will have there, and that's how you will be getting this expression. Tell me if in case you are going to have any doubt, guys. We will be talking about it, but if it's clear, that's great. So you got to know about the harmonic oscillator, isotropic, anisotropic, energy, potential, okay, all these cases, and 1D, 2D and 3D box. You got to know about all these things now. If I'm going to talk about the next thing, after knowing about these ones, what is the next thing you have to consider? So now you need to know about the, we can say, expectation value case, perturbation related tricks I'll be sharing right now, okay, probability case, That's what you need to know. Mostly you are gonna get the questions from these sections. There is even another topic which is commutator bracket and all, but for that, Vijay, okay, let me just tell you. अगर आप यहाँ पर, मैंने ये वाला सिमेट्रिक आइसोट्रॉपिक केस लिया था, ठीक है। अब मैंने यहाँ पे बोला कि ओमेगा एक्स और ओमेगा वाई क्या है, सेम है, ओमेगा है, तो मैंने यहाँ पे कॉमन लिया और कॉफिशिएंट भी दोनों के सेम थे। मैंने आपको यहाँ पे एन आइसोट्रॉपिक के केस में एक जनरल फॉर्मूला बताया, जब ओमेगा एक्स और ओमेगा वाई इक्वल नहीं है तो मैंने अलग अलग लिख दिया। बट एट द सेम टाइम मैं यहाँ कंसीडर करूंगी कि ओमेगा एक्स और ओमेगा वाई क्या है, इक्वल है फॉर आइसोट्रॉपिक। तो जब ये इक्वल है तो मैं इनको किससे रिप्लेस कर सकती हूँ, ओमेगा से, ठीक है। तो मैं यहाँ से एक्स और वाई का सफिक्स हटा देती हूँ सबसे पहले तो, ठीक है, क्योंकि मैंने बोला इक्वल है। अब ये किस केस की बात कर रहे हैं हम, ये वाले केस की। अब यहाँ से हटा देते हैं, एक बार इसको समझ लेते हैं। नाउ एच कट ओमेगा तो कॉमन ले लेंगे, तो यहाँ से ब्रैकेट ब्रैकेट ऐड हो जाएगा, बिकॉज एच कट ओमेगा विल बी कॉमन, एन एक्स प्लस एन वाई plus half means what, 1. So you are just adding it, and h cut omega you have taken common. So this is how you got the expression like that. Let me know. Okay, that's great. Done. Harita, it's actually important, but if you will see the number of questions in the previous years, okay, or the type of questions, so you will be getting the idea, like on the preference basis how you have to consider the topics, okay, or what you actually need to prepare from that. So in the hydrogen atom topic itself, we are having some of the tricks, some of those type of expressions. If you will be preparing them, again you will feel confident about solving those questions. Reason behind it, most of the questions are expected from that section, okay. So it's up to you, like how on the basis of the preferred topics you are gonna take the topics one by one. See, even if you will name a topic now which is like, which has been not asked till now in the exam, so there are still some chances of getting that question in the exam. Reason, we can't expect all the questions to be same as the previous years, or all the questions to be quite easy, okay, or what we are expecting in the exam to be there. So all those questions will be there. No, reason behind it, it's exam first of all. Second thing, in the exam you are getting choices in part A, part B, part C. You are having choices that do only these many questions out of these given questions. So even let's say 1, 2, 3 or at least 5 questions they have added in such a way which are the new ones, which are related to the topics from where the questions have not been asked even once till now, and they can be from different subjects. So still you are having scope to score good marks. Reason, again your cutoff is not 200 out of 200, okay, or to clear the exam or to have good rank you don't need 200 out of 200, and the main thing, choice is there. तो वो आप एक्सपेक्ट कर सकते हैं। देखिए एग्जाम में मान लीजिए एक क्वेश्चन डिफिकल्ट है या कुछ अलग सा आ गया जो आपने एक्सपेक्ट किया ही नहीं था कि एग्जाम में होगा, ठीक है, तो क्या उस केस में आपको टेंशन लेने की जरूरत है क्या? बिल्कुल नहीं है। क्यों? क्योंकि आपके पास चॉइस भी है, आपके पास जो ओवरऑल मार्क्स है उसमें भी इवन इफ इट्स लाइक मोर देन 5 यू आर फाइंडिंग, तो भी आपके पास में अगेन बहुत सारे और क्वेश्चंस हैं एग्जाम में, ठीक है। तो हर एक टॉपिक के लिए बहुत ज्यादा वरी तो नहीं करना है, बट जितना एग्जाम से पहले टाइम है, जितनी पॉसिबिलिटी है और जितना अच्छे से कर सकते हैं, मीन्स आई विल नॉट से कि एक सिलेबस का एक एक टॉपिक अच्छे से पढ़ो, नहीं, बट जितना पढ़ो ऐसे पढ़ो कि वो रिवीजन बहुत बार कर पाओ आप, ठीक है। उससे क्या होगा कि यू विल बी एबल टू रिलेट दोज कॉन्सेप्ट्स विद द क्वेश्चंस इन द एग्जाम, यू विल बी एबल टू like get the idea about those topics or related to the topics which you have prepared and you are going to get the questions in the exam. तो आप एटलीस्ट उनको रिलेट करके उन क्वेश्चंस को अच्छे से सॉल्व कर पाएंगे। बट यहाँ पे हमने बहुत सारे टॉपिक्स, सारे सिलेबस के सारे टॉपिक्स पढ़ लिया आपने सिलेबस का, ठीक है, लेकिन अब आपको वो फॉर्मूले याद नहीं है। क्यों? क्योंकि पढ़ने में हम इतना बिजी हो गए थे कि हमने रिवीजन किया ही नहीं, हमें रिवीजन का टाइम नहीं मिला, और किया तो 2 बार या 4 बार किया। टॉपिक्स इतने सारे, सिर्फ 2 या 4 बार रिवीजन से क्या होगा, है ना। तो एग्जाम में हमें इतने सारे टॉपिक्स में से इतना कुछ रिलेट करना है, मीन्स so many times revision is required. even आप लिमिटेड पोर्शन कर रहे हैं, लिमिटेड टॉपिक्स को कवर अप कर रहे हैं, बट रिवीजन ज्यादा से ज्यादा होगा तो आइडियाज अपने आप डेवलप होंगे। एक टॉपिक का कॉन्सेप्ट दूसरी जगह पे इजीली यूज कर पाएंगे। तो वो आइडियाज डेवलप करने के लिए इंपॉर्टेंट है कि टॉपिक्स पे कमांड हो, फॉर्मूले पे कमांड हो, ऐसे टिप्स पे होने चाहिए। कोई क्वेश्चन देखा, अच्छा ये मैंने पढ़ा था, अच्छा अच्छा ये वाला फॉर्मूला, दैट्स इट। टिप्स पे होना मतलब याद होना चाहिए, इट्स नॉट कि मतलब लिखा है नहीं, लाइक ऐसे एकदम से रिलेट हो जाए, है ना। तो दैट्स इंपॉर्टेंट। डन done, okay guys, so that's how, like, one by one even we will try to talk about so many things, but this is important, do the revision n number of times, जितना ज्यादा possible है आपके लिए। सिर्फ 2 बार 4 बार या 5 बार नहीं, 10 बार कर सकते हैं, 15 बार कर सकते हैं, 20 बार कर सकते हैं, 30 बार कर सकते हैं, जितना ज्यादा बार रिवीजन कर सकता है। अब किसी के लिए सिर्फ 5 ही बार पॉसिबल है तो वो अलग बात है, दे कैन गो फॉर जस्ट 5 टाइम रिवीजन, बट इफ यू आर गोना ट्राई एंड यू कैन डू और ट्राई टू मैनेज टू डू द रिवीजन 5 times, more than 5 times basically, so it's gonna be so much good for you. Revision is the key to success. इतना समझ लीजिए कि आपको अगर अच्छा स्कोर करना है, अच्छी रैंक लानी है, जो भी पढ़ेंगे रिवीजन ज्यादा से ज्यादा जितना करेंगे उतना अच्छा रिजल्ट रहेगा। डन, ओके गाइज, let's talk about it. Vijay, we will also be taking the questions from the previous years, so you will get to know that what kind of questions you can expect in the exam. Okay, I'll be taking those questions too. Now let's go for the next point discussion, guys. So as I was saying, I will be talking about the perturbation theory based some of the tricks here, because now just we will be having some more time in this session. तो थोड़ा और cover up करते हैं। On Friday, this Friday, after one day, okay, I will be having one more session. I will plan it for quantum mechanics itself. So I'll be taking the related questions and more concepts there. ओके, सो हम एक और सेशन प्लान करेंगे जिसपे हम क्वेश्चंस और जो और कॉन्सेप्ट्स हैं क्वेश्चंस के साथ में रिलेट करके उनको हम कंसीडर करेंगे, ठीक है। लेट्स टॉक अबाउट सम ऑफ द ट्रिक्स राइट नाउ। If I'm going to talk about the next thing here, guys, I would like to tell you about the perturbation theory here. Mainly the tricks I will be considering. So if I'm going to talk about those tricks, for example, there is a constant perturbation, and this is also a question from the previous years. For example, 0 to L, 0 L by 2 is there. So in that case, if I'm going to talk about, this is the V naught by 2, this is the V naught. I have shown you the 1D box potential, it was 0. Okay, the potential value was 0 for a particular range. But here I have taken some value of the potential, it is V naught by 2 and it is V naught. What actually is the perturbation? The perturbation means any kind of disturbance in the system. Okay, some changes in the system. So here it is the change in the system which has been considered. Means if I want to find the first order correction to the ground state energy for any such system where the perturbation applied to the system is what? The change, the disturbance, okay? That is a constant value. So when it is a constant value and you want to find the first order correction to the ground state energy, get to know about one thing. You just have to multiply the perturbation applied to the system with the probability of finding the particle in that region where the perturbation has been applied. So here V naught by 2 perturbation has been applied in the half of the region. So what is the probability of finding the particle in half of the region or one of the box out of 2? Let's say these are 2 boxes, 0 to L by 2 one box, L by 2 to L other box. Okay, we'll be trying to do that too, Harita. Otherwise, in our special sessions, as we discuss some of the topics there too, so you can join my sessions there as well. I will try to take those PYQs related to most of the topics there too. तो अगर हम यहाँ नहीं भी कंसीडर करते तो स्पेशल में यू कैन टेल मी वंस, ठीक है, हम कंसीडर करेंगे। वाइल आई एम गोना ट्राई कि मोस्ट ऑफ द जो इम्पॉर्टेंट टॉपिक्स हैं वो हम यहाँ पे अभी कंसीडर करें, लाइक आज के सेशन में और फ्राइडे सेशन में, ठीक है। बट स्टिल अगर आप स्पेशल क्लासेस भी ज्वाइन करते हैं तो आप मुझे बता सकते हैं। सो फॉर constant perturbation, and I was talking about it like we are going to consider there are 2 boxes and equal length boxes. So what is the probability of finding the particle in one side of the box? That's half. Okay, equal probability will be there. So V naught by 2 is the perturbation applied in this half region, and the probability of finding the particle is 1 upon 2. Plus V naught is the perturbation applied to the other half of the system, and the probability is 1 upon 2. So V naught by 4 plus V naught by 2, that's going to be 3 V naught by 4. This is the value of the first order correction to the energy in the ground state in case of constant perturbation. That's how you will be finding it. perturbation multiplied with the probability. Okay, and how you will proceed further, that is what I have considered here. Kuldeep, that's a plus course class at 9 o'clock. Okay, so वो प्लस कोर्स की क्लास है. वैसे स्पेशल जो हो रही थी वो 6:30 पे हो रही थी, बट आज क्योंकि हमारा यहाँ पे सेशन है तो वो आज 6:30 वाली स्पेशल सेशन नहीं है. अदरवाइज नॉर्मली आई वाज कंडक्टिंग दैट सेशन टू. डन. Now let's talk about the next thing. This was all about the constant perturbation. You have to keep it in mind. It's gonna be very good trick which saves your time and gives you the answer quickly and easily. So it's good to know it and even to use it easily in the exam to score good marks. Done. Now let's talk about the next thing here. Maybe the perturbation applied to the system is not a constant perturbation. So then what will happen? Excuse me. In that case, if it's a variable perturbation, what I want to say by saying variable means beta x, sin x, anything can be there. So it's what? Variable perturbation. In that case, if you want to find the first order correction to the ground state energy, done. In that case, what will happen? It's going to be, you have to just find the average or expectation value of the perturbation applied to the system. Means if you will be finding its average value, now these are the two different cases I was talking about. So let's say you got the range x lying between 0 to a. So what is the average? How you will take? It's a trick. So trick kind of thing we do here. So initial value, final value, two values are there. To find its average, 0 plus a by 2, two values. So 0 plus a by 2, that's a by 2. Just write it. You will get beta a by 2. That's the answer. Sin x, depending on the range, or the average value of sin x will be what? 1/2 you take, or cos x 1/2. So simply those average you have to take to find the first order correction to the ground state energy. That's it. This is how you will be able to get it. That's great, Kuldeep. Thank you so much. Done. Okay guys, I hope it's clear to everyone now. More discussion now I will be doing on Friday. Okay. And that's going to be our session which will start around 4 o'clock itself. So you all can join that session too. We will be keeping it this much right now, guys. Whatever we have discussed in this session today, I hope that's clear. Do the revision of everything. As I have told you, revision is very much important. Anywhere if you will have any doubt, tell me in the next session. I'll try to consider that as well. Okay. Thank you so much everyone for joining this session, and our next class will have more important questions, concepts and topics in it. So don't miss that. Thank you so much everyone for joining this session, and let me just show you the important slides once again. So here we are going to have like slide regarding the Unacademy learning app. We are going to have the well structured and well planned courses there. If anybody wants to join and attend the regular live classes of well structured and well planned courses on Unacademy, then you can take the subscription. Here is the another slide. Here is the another slide. Here is the slide regarding the community. Okay, so this is how you are gonna know about it. While if I'm gonna talk about the next thing here, so as I have told you, that new batch will be starting soon on Unacademy. So if you don't want to miss it, you can take the subscription. Whenever you will proceed further to take the subscription, use and apply the referral code, that's Anjali A Live, to get the discount in the total subscription amount. Okay, and the another thing is, if I'm going to talk about the next point here, that's going to be, this course will start on 11th August, but along with this course, so many other courses are also going on. So if you don't want to miss them, you can take the subscription and start your preparation under the guidance of top educators. This is another important like information about the learning festival August. So for that, you can have a look at this. Like we are going to have some important details. Okay, I hope it's going to be helpful for every one of you guys. Now, next slide is regarding the benefits you will be getting on Iconic subscription, or if you will take the Iconic subscription. And as I've told you, whenever you will proceed further to take the subscription, use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. These are the benefits you will get if you will be taking the Plus subscription, Light subscription, The difference between the plus and the iconic subscription have been shown here. So I hope each and everything is clear to all of you now. Okay guys, let's keep it this much. And thank you so much everyone for joining this session. Our next class now we will have on Friday. I also keep on conducting the special classes, which are the free live sessions. So if you don't want to miss them, you can follow me on Unacademy Learning app and you can see the community post. I generally post about the special session in community, so you will get to know about it there in the learning app. Okay, Unacademy Learning app. And along with that, so many plus courses are even going on right now. So if you don't want to miss them, you can take the Unacademy Plus or the iconic subscription and use and apply the referral code, which is Anjali Alive, as mentioned here on the screen. By using and by applying the referral code, you will be able to get the discount in the total subscription amount as well. Thank you so much everyone for joining this session. Thank you. Let's